Hello, welcome to my channel. In this video, I will be discussing escape velocity. Escape velocity is the velocity that is required for a body to travel so as to escape from the gravitational field of a planetary body. What does it mean? There's this general concept that is known that if you are on the surface of the earth and you throw a stone up, the stone will come back to the earth, meaning that when you stand up and you throw up a stone will follow its trajectory and come back to the surface of the earth. But is it possible for us to throw something up and that body will never return? Yes, it is possible. But for this to happen, that body must be thrown with a velocity that is equals to or greater than the escape velocity. In summary, escape velocity is the minimum velocity that is required for you to throw a body and that body will never fall back to the surface of the earth. It's very important to know this as this is used in rocket technology and astronomy. How do we determine the escape velocity on a how do we determine the escape velocity for a planetary body? It's important for you to note that the escape velocity for every planet, be it the Earth, the Mars, the Jupiter, is determined by some parameters, meaning that the escape velocity for the Earth is different from the escape velocity from the Mars and is different from the escape velocity from the Moon. So, how do we determine the escape velocity of a planetary body? Using the principle of conservation of energy, when a body is thrown from a planetary body, the principle of conservation of energy states that the initial mechanical energy of that body will be equals to the final mechanical energy. And we know that the mechanical energy is equals to the kinetic energy plus potential energy. And in this case, it will be gravitational potential energy of the body. If you don't know what gravitational potential energy is, watch my video on gravitational potential energy and gravitational potential. So, for us to derive the escape velocity of a planet, we need to use the principle of conservation of energy. And the initial kinetic energy plus the initial gravitational potential energy must be equals to the final kinetic energy plus the final gravitational potential energy of the body. So, what is kinetic energy? We know that the kinetic energy is half mv squared. So, this is the initial kinetic energy of the body. Okay, and the initial potential energy of the body is the gravitational potential energy of the body. And the gravitational potential energy of a body is equals to minus the gravitational constant times the mass of the planet multiplied by the mass of the body divided by the radius of the planetary body. Okay, so let me explain what this is. Let's say someone is on the surface of the earth And let's say someone is on the surface of the earth and you want to determine the escape velocity. Okay, you need to know the mass of the earth. Okay, and the mass of the body that you want to throw to escape the gravitational field of the planetary body you are determining, in this case the earth. And you also need to know the radius of the planetary body. Okay, so when you input it into this formula, that will give you the escape velocity of that planetary body. Okay, now let's continue with this. We have written the initial kinetic energy and the initial potential energy of the body, which is the gravitational potential energy. This must be equals to the final kinetic energy. The final kinetic energy of the body will be zero. Okay, meaning that after the body is thrown up and is made to travel, just at the points when it escape the gravitational field of the planetary body we are dealing with, the kinetic energy will be zero. Okay, and also the gravitational potential energy at that point is zero. That is because it is no more under the influence of the planetary body we are talking about, in this case the earth. Okay, now from this equation, when we evaluate it further, we're going to get 1 over 2 mv squared minus, we got this minus because plus times minus is minus this, the gravitational constant multiplied by the mass of the planet we are talking about, the planetary body we are talking about, times the mass of the body, all over the radius of the planetary body. And when we evaluate, this is equals to zero. When we evaluate this further, it will give us, when we bring this one to this side, we know by the time the minus cross the equality sign, it will become plus. And we bring this to this side, it gives us half mv squared is equals to plus gmp m all over r. Okay, so since this is plus, we don't need to write it there. Okay, that is conventional in mathematics, right? So now the m on this side will cancel the m on this side. How does it happen? Divide both sides by m. When you divide this side by m and you divide this side by m, it will give you, the two m's will cancel out on either side of the equation. So what we have left is half v squared is equals to g m p all over r. Okay, now let's make v the subject of the formula. These two will come to this side. Okay, and this square will become the square root on this side, so that we have v is equals to gmp all over r times 2 square root of r. Okay, now if we are talking about the earth, this mp will be mass of the earth, right? So this, if we are talking about earth now, okay, this will be 2gm e, this is mass of the earth, all over r e, radius of the earth, square root. Okay, so the escape velocity is therefore 2 times the gravitational constant multiplied by the mass of the earth all over radius of the earth. Okay, but if you watch my video on gravitational potential and gravitational potential energy, we derived g, which is acceleration due to gravity, to be equals to GME all over R squared, all over RE squared. So if we substitute it in this equation, okay, if we substitute it in this equation, it's going to give us, since we have GME over RE, so all we need to do is to multiply it by another RE. So this will give us velocity, the escape velocity is equals to 2GRE square root. So in this final formula, you can see that the escape velocity of a body from a planetary body is not affected by the mass of the body, okay? But rather, it is determined by the acceleration due to gravity of the planetary body, and indirectly also determined by the gravitational constant and the mass of the planetary body, in this case, the Earth. Okay, so this is the formula to derive the escape velocity. Okay, the escape velocity. So if we know G, acceleration due to gravity, to be 9.8 times 9.8 meter per second squared, and we know the radius of the Earth to be is equals to 6.37 times 10 raised to power 6 meters. If we input it into this equation, let's see what we get. So V, the escape velocity for the Earth, will be equals to 2 times 9.8 times 6.37 times 10 raised to power 6. Let's find the square root of this. This is equals to 11.17 times 10 raised to power 3 meter per second squared. So this this is the escape velocity from the surface of the Earth, meaning that for a body to move beyond the influence of the gravitational field of the Earth, the body must be thrown with an initial velocity of 11.17 times 10 raised to power 3 meter per second squared, which is otherwise equals to 11.17 kilometer per second squared. Okay. If you enjoyed this video, kindly like, subscribe, and share. When you click the subscription button, a bell icon will pop up. Click it for you to be notified when I upload new videos. Till I see you in my next video. Thank you for watching, and bye bye.